Hey guys and gals, what is good? What is good today? How are y'all doing? Turn it up. Appreciate you hitting that play button. You know I love that. You know I love it. Give me a sec, guys and gals. Got to get it back into the streaming mode. Couple of days away from it. Few days actually. Whoops, pressed the wrong one. Give me a sec, just want to make sure we're good. He's away from it. Yes, all right. Beautiful, just like you guys and gals. What is good and handsome? Let's go. How's it going? How is it going, everybody's? How's it going? I'll get you all excited and pumped up. Turn it up. Quick shout outs, and then we're gonna get to doing some learning. Am I on the right one here? Is it this one? I think so. Da, 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 da. Yeah, man, I gotta get back into the streaming mode. All right, here we go. Quick shout outs. Twitch and YouTube followers. Let's begin with Twitch. Let's go. Throwing it out for Nicole Trey 66, Bart number 1, Jim Jam 1238, Kazert 20, Gavin 555, Kamikaze ML. I hope you're still around. Appreciate you, brother. Don't kamikaze yourself. I love having you around, my guy. All right. I care, man. I love you. Okay? It's great to have you. Let's turn it up. Ducky. Gotta do this. I have to do this. As a matter of fact, it's Ducky is the reason that we are doing that now. Let's go. And last but not least, let's throw it out there for Wicked Stats. Man, I really got to get it back into the streamer mode. Yeah. I don't know, maybe I'll go on a tangent. I don't know, guys. But anyways, let me continue and finish here with the shouty outies, YouTube followers, WX87, Flawless Hack, Salt of the Earth Ministry, and Ayawi, A-Y-A, yeah, and we. Ayawi, let's go. Yerp. I don't know why I do that, but it's fun. Fun to do. Okay, and then we're going to do this, and then we're going to get to Johnny going on a tangent, maybe. I don't know, we'll see. All right, this is for you supporters, followers of the channel. Also, you viewers, man, the ones that are watching this coding content, you guys are great. So great to have you. Truly is. Thank you for learning along here with Johnny, WhiskeyTango Coding, Twitch and YouTube. That's right, that's right, that's right. That's for you guys and gals, followers, supporters, lurkers and twerkers and viewers. Johnny appreciates you, every single one of you. Turn it up. Okay, go on a quick tangent here. I'm going to try my best not to go like too terrible, guys. I've been off for a few days. Well, the weekend went by, and then I think Monday was a holiday and whatever. I have been working and stuff too. Man, where do I begin? Let me just say my landlord, I've been in the same place for 8 years, okay? Paying my rent, doing all the normal stuff, keeping the peace, being of good behavior, not causing the landlord's troubles or problems, not complaining, you know. I moved into this place with a shower head hanging off wires, like metal wires, and it's still like that. Still like that. So, anyways, the basement is basically a revolving door, if you will. In the 8 years I've been here, literally the basement is now on their 5th set of tenants. 5th. So that means on average, tenants downstairs last maybe 1.6 years. Okay? So, my landlord's being a jerk. A literal jerk. I don't know how much more time I got in this place. The struggle is real, okay? And I'm not going to get into my circumstances, but it's not going to be easy for me to find another place. Not with being a freelance coder. Okay? Living off of bologna sandwiches and wieners. But I make sure my kid eats pork chops or whatever, steak, potatoes, I make sure he eats. He comes first. So I don't care if I starve or whatever, or have cereal for supper. Anyways, my landlord's being a jerk, total jerk. I don't cause any problems. I don't complain about stuff. I leave the neighbors alone. For the most part, I'm usually nice. But these neighbors, I don't know. I've told her in the past, no dogs. No dogs. Okay? I swear to God, she does it just to spite me. So the tenants before had no dogs, but the girl before did have a dog. He was not a bad dog, and she was pretty good about cleaning up the poo. I was doing backyard work. The grass needed to be cut. My landlord's telling me I have to move this treehouse I built for my kid. The thing's like 600 pounds or so. I don't have money to move it. I took pride in building this thing. Take pride. I love the thing. It's a cool little standing, not a tree fort, but like a fort. When my kid was younger. It's not a permanent structure, but it's on stilts and whatever. She's making me move it because she's like using some lame excuse that it's hard to cut the grass or some BS. And I'm like, I'm the one that cuts the grass. I do it every time. It doesn't matter who's downstairs. I shovel the front, I shovel the back. I cut the grass front and back. I do it all. I do all the work. The tree trimming. On top of trying to do this for a living, Anyways, man, I have not been in a great mood. It's kind of nice to vent a little bit, but that's why I didn't want to stream for a day or two, because I was just... If you could see me fuming, you could probably see the fuming coming off of me, because... And for some reason in society, you can't punch people out. I don't know why. It's crazy. But back in the old school days, we had no problems doing that sort of stuff. You had a problem with somebody, yeah, went toe to toe. Anyways, not nowadays. It's too fluffy. Fluffy world. So yeah, I need to kind of just get my head back straight here, guys. So because I don't want to give you guys like, I want to keep it positive, right? So I don't want to go on that anymore, but I just wanted to keep it simple. My landlord's being an evil jerk. So, and there's other things, but I don't want to get into it. So, yeah, I got to keep the vibes up for you guys. So, but I've been also working on my wind forms. I don't know if you guys checked out my YT channel if you're on Twitch listening, but I've been in the past. I did some random roll like for lotteries and stuff. Lucky for Life, Mega Millions. What else? The American versions, Mega Millions, Powerball, Canadian versions, Lotto Max, Lotto 649. I have others. I have Pick 5, Pick 4, Pick 3. But I did the 5 main ones, just doing videos on those, and then I kind of had to I had to work on my code. It's C# code, guys, when you're working with wind forms. So I'm kind of jumping back and forth between C++ brain and C# brain. So this should be fun. It shouldn't be too bad. Yeah, my random numbers were duplicating and stuff. That's because like I hadn't opened it for a bit, and with the update and stuff, Visual Studio was recommending some stuff. And so I commented out a bunch of stuff, some lines of code, and then I'm streaming it, and I'm like, oh great, I'm getting duplicate numbers. Wow, isn't this embarrassing? I am gonna do the numbers again. So all I could say was, guys, I just have to go back to editing the code. Really, they don't know what I did because I never explained it. You guys are kind of getting it now, I guess. But yeah, I commented out some lines of code that did sort of the error checking sort of things. I do what's called leapfrogging with my private variables and my local variables that are inside of a it's not a function but a button click event sort of thing. Anyways, yeah, so I've been doing that. And yeah, I was doing a bunch of streams for, because I'm trying to, I don't know, make some money off these apps. I'm trying to do something here, create something that you guys could buy. It's not crazy expensive, it's cheaper than a video game. Half the price of a video game, to be honest. Actually, probably even less. What's a video game now? $100? Anyways, all right. That's my story. Again, are you guys watching? You're awesome, by the way. You really are. I mean that. Like, I love people that are learning. Yeah, not to go on a tangent, but yeah, you guys are awesome. Keep learning. 120 IQ club. Crazy world out there. You're better. So there you have it. I said it. Yeah. Shall we get to some learning? I think so. Okay. All right. Where were we last? Let's go. Flick that switch in the old brain molecules. Guys, gals. Again, if you're listening to me go on my kind of little stories or whatever, if you don't feel like listening, by all means, you're not going to hurt my feelings, right? I'm just going to look at it like you just want to get to learning. So you can skip forward ahead, kind of skip my rants. Well, it's not really a rant, but just kind of giving you an update of what's been happening. Again, I don't know how long I'm going to have in this place, so video wise, I don't know if you guys are gonna see me around. I don't know what's happening. My future, I don't know. What's up? Oh, joy. Let's do this. Because why not? That always puts a... Yeah, let's go. Ducky. Okay. Last we're working on, again, guys, flick that switch in the old brain. It's time to learn. Time to learn. You guys love this. You know it. Trying to make it easy and easily understandable for you guys and gals, okay? Now, don't get me wrong. I'm not treating you guys like dummies. You're not dummies, okay? If you're watching my content, right off the hop, I already know you're an intelligent person, okay? Just because you're watching the content. What's the rest of the world watching? Toxic drama, toxicity, and garbage. That's what they're watching. Okay, not you guys. So you guys are watching, I already automatically know you guys are intelligent people. Okay? You guys are awesome. So I will kind of I feel like I'm over explaining stuff, you know, but I also want to make sure that you guys that I'm being clear. I guess maybe I'm being over clear. I don't know. But just making sure that you guys understand. Okay? All right. I'm going to try to get my words out today. Let's go! So we were working on integers and variables and talking about a lot of the good stuff that we need to know. Working with characters, ASCII, characters and numbers, the ASCII table. We're going to do a little more of that too, guys. It's going to be fun. Stay tuned. I hope this all works out. I keep doing this for you guys because there's a lot here. This is a whole course. And again, look at them like there's two ways you could do this. You could listen to me talk like they're audiobooks. Just take notes of where kind of you are in I don't know how you would do it, but you might want to see some of the visuals that we'll be doing on Visual Studio, right? So I don't know. It's not full on 100% an audio book, but I think you can kind of listen along. So anyways, carry on. You do kind of need the visuals too. All right. Printing characters based on numbers. That's kind of what we did through the ASCII table. That was fun. Special printing characters. There's something that I wanted to do that you guys didn't get to see. Okay, so this is built. Let's clean up stuff. Let's clean things up. Special printing characters, yeah. That's what we're gonna do. Okay. All right. Whoops, don't want that. Okay. Whoops. So I'll just kind of do this. I think I already we'll snipping tool, and I've already kind of showed you these, but here we go again. Okay. So you could use these characters in your string literals, okay? This one I wanted to do the bell alert. So we have a backspace you could do. You could have a form feed. To me, I'm thinking printer when I hear that. The new line we've used a lot. Carriage return. I think of a typewriter, like an old school typewriter, the real deal. I think of that, carriage return. Tabs are normal with a keyboard. Vertical tab, I haven't done, you could do that. That's my brain's thinking alignment. How messed up would the alignment be is what I'm thinking. Single quotes, I showed you how to do that. So if you want single quotes and even double quotes in your string literals, you have to use the backslash, okay? You can have a question mark, I guess. Why wouldn't you be able to anyways? I don't know. If you need a backslash, you have to do a double backslash. And then we got octal and hexadecimal notation, which I think might be, I haven't used it much, but I'm thinking maybe it gives you an output. Like if you, it's kind of like, my way of thinking is, like if you're being explicit about something, let's say you want 3 decimal places or something, I'm thinking, or maybe your return being hexadecimal notation. That's what I'm thinking. I don't know. So let's do this just for fun, just so you can see. And I'm gonna go like this, and I don't know, I guess we'll just go like this, and then we'll put in the bell alert, and then I guess standard end line. Sure, why not? Okay, whoops. And let's build. And what did I do? What? Or 34. What did I? Oh, right here. I could see it. For a second there, I couldn't see it, but then I'm thinking, okay, there you guys go. Syntax, right? Right here is what you're seeing here is called a compiler error. It's pre-runtime errors. Okay. So there. Right? So I was just missing my scope resolution operator. Okay? It wasn't exactly clear what it was meaning, but here we go. We can see it right here. It's telling me. Okay, let's build it and run. Let me just let me pause the music for a sec. Listen to this. I'll run it again. That's from that's your typical Windows sound, right? Bell alert. And you could actually get the sound. It's kind of cool, huh? I meant to do that when we were talking about printing characters before, but here we are now. It's all good. I eventually get it done. All right, constants. All right, we're going to do some reading. Working on the course outline. Like variables, constants are data storage locations. Okay, just like variables, right? I don't mean to go on a sidetrack, but normally what I'll do, there's actually a macro I use, but I'll just go like this, C underscore pi, for example, and 3.1415, I think it is. Pi. Yeah, 3.14159, so it's actually 16. So I had those kind of memorized. All right, there. Okay. Let's see if I can find my macro, but usually it's written like this: m pi equals. Actually, I don't even need the m pi, but m for macro. So the reason I'm doing this is something else I forgot. Const, right? Consting means when you const data type, declaring, and we're also kind of declaring it as a constant. Constant means that this value can never be changed. Like if you run a program, maybe somewhere down your code you have where the value gets changed. Like variables, they get changed, right? Int x equals 0, for example, right? Down your code, eventually your x value gets updated whether it's through you or through some sort of calculation, right? So again, take note, your variables can be updated. I call it updated just for simplicity's sake, right? Now, if you've been following along, I hope you have been. If you haven't, I recommend you kind of follow the series, all right? This is like a lecture. What the... I don't normally get commercials on this, but because I paused it, maybe that's why. I don't know. So yeah, treat these videos kind of like a lecture, guys. Okay, I know it's not exciting and all that. I try to do visuals and that, and I try to keep it entertaining. All right. Again, if you're wanting to learn this, your commitment's going to be higher than most, right? Which is great. Okay. And again, yeah, like for me, I wanted to learn this, so I dove right in. Right? Get rid of all distractions, life distractions, and just dig right in. When you want to do something, your energy and drive, your commitment is a lot higher, right? Because you want to do it. All right, so I just wanted to say that for an example, right? That's a constant, right? And we'll use const in front of it. I kind of jumped ahead, but why not? Let's do that. Let's continue. Unlike variables, and as the name implies, constants don't change, right? So the const here means it basically forces this variable. You can't update it. It just can't be done. Okay, it's kind of like locking the variable. Think of const like a lock. It puts a lock on your variable so that this value never gets changed, right? We obviously understand what constants mean in regards to mathematics, right? Again, hopefully you haven't been sleeping in math class. Don't sleep in fractions class, kids. They're really not that hard. I think the hardest part for people is the adding and subtracting fractions, but when you're multiplying, dividing fractions, please, it's way too easy. All right, you must initialize a constant when you create it, right? Just like as I'm showing here, I'm initializing, right? Declare. Technically speaking, we're declaring. Well, normally, when we're declaring, it's just the data type. This is more of a, I don't know. I don't want to go off on a side note here, but I'm looking at these together, and it's actually constant. I've kind of got it backwards. Constant. Okay, there we go. And what it just said there is you must initialize, right? All constants have to have a value. Okay. It can't. So the point is it can't be like this. Okay. Right here is probably going to tell me show potential, right? Give it a value. Well, every variable gets initialized to 0, but okay. The point is you must initialize it. Okay? C++ has two types of constants. Okay, I'll get rid of this. I'm just going to go like this. And like this. There we go. I don't like when it does that. Okay. All right, those are called literal, like literal, you know what I mean? And symbolic. Okay, this might be kind of literal, I think it's easy to understand, but I'll try my best to explain it. We'll see how it goes. Okay, literal constants. Okay, literal. All right, so we'll go like this and like this. There we go. A literal constant is a value typed directly into your program where it is needed. For example, int x equals 34. So we're being literal, okay? I know it's kind of vague, but we're literally being explicit if you want to look at it like that. My age is a variable of type int. 39, well actually 34, is a literal constant, right? So could look at it that way. I never looked at it that way. I always kind of separate the concept of constant being something like this. This is what I associate it with. Pi, for example. Technically speaking, we're being literal. It's a literal value we're storing into X. You can't assign a value to 34 and its value can't be changed. I don't know why I would say that. Technically speaking, I mean, it could be changed. I know this could be changed down the code. Let's say we had some kind of function or something, right? Maybe they just kind of trying to keep it generalized until you get a little bit more advanced at this. I don't know. So they have, and it's no different than what I have, 39, okay? Exact same thing. We're basically we're initializing. That's all I do. I don't think of this literal constant, symbolic constant stuff, right? I don't really care much about it. Like, it's not really, it's something that you need to be aware of, but I don't think you really have to super focus on it. Maybe it's a part of an exam. I don't know. Again, my point is, whenever I think of a constant, I think of pi, right? Just my math brain, I guess. Right? And then here, when I do stuff like this, my brain is just thinking I'm initializing 34 to x. I'm initializing. Declare initialize. Declare initialize. That's all I look at it. I don't look at these as a constant. They're calling them literal constants. That's what they're calling it here. Again, this is older, an older course, but again, the theory, like I said, guys, it's all the same. Whether they teach this stuff now, I don't know. Okay, so let's just carry on. So symbolic constants, so those are literal. And let's look at symbolic. What do they mean by symbolic constants? A symbolic constant is a constant that is represented by a name. Okay. Oh, this is getting cooler. So just as a variable is represented, unlike a variable, however, a constant is initialized. Its value can't be changed. I don't know why it's saying that, because I know down code somewhere we're not actually being explicit saying const here, right? That's the separation for me. Again, I wouldn't super focus on this stuff, guys, right? But I think what they're doing here with symbolic constants is kind of cool. So let's follow along. All right, if your program has an integer variable named students and another named classes, okay, they're integer variables. Okay, so one's called students, and I guess I'll type it instead of being lazy, and then we'll have to initialize it. Let's say we don't know how many students. Oh, that's something else entirely. Okay, so we have a variable named students. It's saying it's an integer. And classes. Okay, now we could kind of enter values after the fact, but we're initializing to 0 for now. All right, so if you knew each class consisted of 15 students, you would go here's the formula. I don't know why it's not written different, but what they have is students equals, I had to kind of do it this way first just so I could show you guys, right? Classes and then multiplied by 15. Okay, so that would be our little formula. I'll just keep that for now, because technically I could go like this just to see the result, right? And then we're gonna go students, ST. There we go. Okay. Okay, if we wanted to see our return or output. Okay, let's continue reading. So unlike a variable, however, a constant is initialized. Its value can't be... Okay, I don't know why I'm reading that again. If your program has an integer variable named students and another named classes, you could compute how many students you have given a known number of classes. If you knew each class consisted of 15 students, technically speaking, you could create a variable for this too, right? Normally we don't write. So the main point is this isn't normal to write this like this. And I'll explain in the future. Let's just say that if you have your declarations done at the top, down your code, let's say you had 500 lines of code and you wanted to change the value of my age, right? You could do it right here at one location and then it would basically get updated, because you're going to have to look for this line. Let's say this is line 447, right? For example, right? You would have to look for this line to change that value. That's the point. That's why this is done at the top, being your local variables, right? Okay. In this example, I'm going to speed this up. 15 is a literal constant. Okay? Yes. It is. Okay? I'm starting to grasp it. All right. All right. Coolio. Your code would be easier to read and easier to maintain if you substituted a symbolic constant for this value. Ah, that's what they mean. A symbolic constant. Okay. I look at this as a value, right? I mean, it's not changed technically. It's a literal constant. I guess, sure. All right, theory. So we could rewrite the formula, but we would have to, instead, we have to declare something like this. Int students. This is where we're doing symbolic constants, guys. Okay, so really I just look at it like creating creating a variable and initializing it. That's how I look at it. Okay? But it's part of the lingo. All right? So if somebody throws a literal constant at you, then you understand what they mean, right? If somebody says in the sentence, use a symbolic constant, you're going to know what it means, okay? Students per class, okay? And equals 15. Okay, so here's the point. You want this at the top of your code so that you're not looking for this value 15, it's up here. And you can change it at the top in one spot, and you're not going 500 lines later trying to find this one line of code. Okay, so instead of going, I'm going to copy this variable name because now we're initialize, declare, initialize, initialize, declare, initialize. Okay, I'm just going to copy this. So we created a literal constant, and this is our symbolic constant. So instead of using a literal constant, we're going to use a symbolic constant. There we go, right? So again, let's say this was line 467, or maybe is line 3,467, right? It's a lot of lines of code to look through to try to find, one value that is 15, right? So here's the main point, guys. Okay, don't do this. Okay, you don't want to have. The point is, you don't want to have literal constants on line 3,467. You just don't, because the main goal here is, let's say you need to change this value. It's all at the top of your code here, and all you need to do is change it in one place. Instead of, okay, you understand? All right, cool. I'm going to leave it at that because I think I'm at the over-explaining part. So I'm going to build that, and then we can run it, and we should get an answer of 0. Just kidding. What? Oh, right, because anything times 0 is 0. How many classes, guys? How many classes do we have? Are you in chat? You want to tell me how many classes do you have? What? Cancel. We have, I don't know, let's just say there's 3 classes, okay? All right, so we have to do the same thing here. So we're adding a literal constant to our symbolic constant. Okay, so classes is our, man. Oh, I hate the typing. Don't cheat in typing class, kids. Okay, and students. I'm just gonna go like this. Right, they're both classes, and students per class are both symbolic constants. Okay, and 3 and 17 are both. So let me fix this, guys. I do a lot of copying and pasting. There we go. Control X. Boom. Boom. Okay, there we go. All right. There it is. That's the difference between literal constants and symbolic constants. Okay. Again, I don't know why that's like that here, but that should be there. Okay. This is much better. This is exactly what you want to do. You want to use symbolic constant and a literal, let me say that again. Rewind. Okay. We want to use classes, which is a symbolic constant, and number of students per class is also a symbolic constant. So that's what you want to use in your little formulas. That way you're not looking for, line 3,467, looking for this that, is a literal constant. Okay? Use symbolic constants. All right. And now we should actually get an answer other than 0. 51! Let's go! That was a simple little one, guys. All right. All right, continuing. Speeding things up here. Trying to. Let's get through this. This is all the fun stuff. This theory is easy, guys. Okay? All right. So I've already explained all this, but let's go over and just kind of expand on it with the course outline. So if you later decided to change the number of students in each class, you could do so where you define the constant students per class, right? Being at the top. You can do so because it's much easier to find it at the top of your code than it is 4,000 lines later, right? Excuse me. You could also, you could do so where you define the constant students per class without having to make a change every place you use that value. Yeah, that's the other point, right? Let's say you had students per class and you had 15, the value 15 on one line, right? And the value, I don't know, 36 on another line. Then you're going to be looking for more lines with that value, right? It's just painstaking, right? We're learning this stuff here. It's to make your life easier, guys. Okay? So understanding this right from the get-go, you're going to do this kind of stuff in your code because you know you only need to change it in one place now. Right? It's such a win-win. Okay? 2 ways exist to declare a symbolic constant in C++. The old, traditional, and now obsolete way is with a preprocessor directive called #define. We might do some, but we haven't really done any, but there's this thing called #define, okay? The second and appropriate way to create them is using the const keyword, which I've already showed you. So they're saying don't use this method. Okay. I'll just I'll go like this. Okay. All right, the old, traditional, and now obsolete way is with the preprocessor directive #define. Again, it's the same. It's called the same thing, preprocessor directive. The hashtag includes the same, called a preprocessor directive. Okay. All right. So the second and appropriate way is to create them using the const keyword, which I've done right here, guys. And I think pi, when we're talking about circles, I'm not talking about apple pies, even though it sounds pretty good right now. Use the word constant. That way that value can't be modified or changed either by the user or by the compiler itself. Okay. You'll understand what I mean by that when we get into talking about referencing and dereferencing and such. Hopefully I can get there. I really want to do this for you guys. Okay, again, it's kind of like it's a lecture, all right? It's not a 5-minute how to type one word video that people are looking for. I don't know. Anyways, I'm going to keep going. I don't want to go on a tangent because I think that's ridiculous. Well, I love it when people are here to learn, right? Even if it takes a couple of hours. Think of it as a class, a lecture. That's what we're doing here. Okay, because the number of existing program. Okay, defining constants with hashtag define. We're not going to do any. I'll show an example, but here, right? So this is what they would do. Just as an example, hashtag define, and you could do this at the top. Normally, it's done at the very top, and then you would, just so I don't have to type things, I'm going to go like this, like that. And then you just put the number, and then that's it. It's kind of like, it looks like the macro. That's what it is. Macro can be converted to const expr. Let's just see if it allows us. I don't normally do this kind of stuff, but let's see. Okay, and apply. It actually allowed me to. Okay, I don't normally do this kind of stuff, but it's something that, now you learn something new, you're aware of it. If I go Control Z, that's how you change things. If it's yellow, now your theme, this is my theme that I created. The color coding is probably going to be different with your Visual Studio. I have a video on YouTube on how to kind of create your own custom themes. You're just going to have to put it in chats or comments below if you want to see that video. Just let me know. If I go redo, again, the point is here, I'm saying convert back to the anyways. All right, there we go. I'm just going to go like this. We're talking about hashtag defines. All right, so that's what you would do. You're basically doing the symbolic constant with the literal constant. Because technically speaking, I guess it is a literal constant. I don't look at it that way, but things you learn. Okay, this is just theory. It's all the part of the lingo, guys and gals. Okay. Let's see. Now, note that students per class is of no particular type. Yeah, that's true too. We just defined it, right? That's all we did. We defined it, but there's no type. And what they mean by type is data type. That's what they mean. The program must read it and go, okay, I know this is an integer. If I hover over it, it's probably going to say that. Yeah, see? Look. It knows. Int. Okay, and then here, what's it going to say? It's calling it a hashtag define. And then it's recommending, like you'll see these three little dots. The program will have a suggestion, in quotes, suggestion. Whether you use it or not, it's up to you. Okay? You can take the suggestion or you can ignore it. All right, let's continue. Note that students per class is of no particular type, like for example, int, char, and so on. The preprocessor does a simple text substitution. In this case, every time the preprocessor sees the word students per class, it puts in the text 15. Oh, interesting. Things you learn. Again, I don't normally do this style. I always do the declare, initialize. This is what I look at it as, okay? Declare, initialize. All right. Because the preprocessor runs before the compiler, that's true, right? Line by line, technically speaking, it's going to be going here. Before the compiler, even before we run it, I guess this is already included into your file, right? Our CPP main file. Your compiler never sees your constant. It sees the number 15. Okay? Although the hashtag define looks very easy to use, it should be avoided as it has been declared obsolete in the C++ standard. Maybe it's a C standard? I don't know. I started with C++. A lot of people ask the question, should I start with C before going to C++? You don't need to. The languages are like the C language is actually has a different style of syntax. Okay, all right. This is all syntax, right? What we're doing, it's written different. So you're learning a new style of line writing, okay, or coding, just like C sharp. Okay, and you have to kind of look at code and go, okay, that's the C language. Oh, that's the C sharp language. You know what I mean? You can tell the difference. All right, defining constants with const. Although hashtag define works, a much better way to exist to define constants in C++. All right, so we're going to get rid of this. Okay, that's the old way. I'm just going to go like this. I'll just comment it out. Okay, and then I'll go like this. There we go. Okay, and as a matter of fact, well, I'll just leave it there for now. Okay, the const. Here we go. Okay. Where am I here? Okay, const. We're going to change this. So they have it set up different. That's okay. Const, which is first, and then you declare, which is an int, the data type. In this case, they went kind of a little bit more here than we need to, right? This is kind of being fully explicit, I guess, if you will. Let me go to here and here and here. Okay, so unsigned short int, which is this 0265535. Okay, now again, we could do it a shorter way. I believe all we need to do is type const short. Okay, or it could be fully explicit, I guess, if you want. And then we go like this: Control C, Control V, Control X, Control V, and I'm just going to delete that. Okay, so we've kind of expanded our integer here a little bit more. We've narrowed its range down, right? Just by doing that, we've narrowed the range down to, and same thing with memory, right? We went from 4 bytes to a single byte memory. And then we reduced our range as well, right? So that's why this is important to understand. Okay, guys? So, which makes sense. Maybe this school only has a max of 65,000 kids. Who knows? Right? Maybe they only have 13 classes in total. And there's only allowed, most classes are 30 on average now, I think. We'll never multiply those two values and be higher than 65,000, right? You kind of have to do a little forethinking, right? This is narrowing our range, and we're using less memory too. RAM memory, right? Okay, this example also declares a symbolic constant named students per class, but this time students per class is typed as an unsigned short int. Obviously, we can see that. This method of declaring constants has several advantages in making your code easier to maintain and in preventing bugs. The biggest difference is that this constant has a type, right? I mean, that whole thing is a type, right? Int is still a type. And the compiler can enforce that It is used according to its type. Okay, constants cannot be changed while the program is running. Okay, that's called dynamic. All right, I'm going to just bring that word up now. Okay, right now, static, these are static. And dynamic means running or moving. Okay, things are running. Constants cannot be changed while the program is running. If you need to change students per class, for example, you need to change the code and recompile. Yeah, I'm always building and stuff all the time. Number 10, what's number 10 saying? Yeah, I just gotta go. I gotta build it to get rid of that. Line 10, what's up? I've commented it out. That's wild sauce. That's kind of blowing my mind a little bit. Why won't that go away? That normally does. So, I'm just gonna go like this. I'm gonna copy this, and I just want to go Control Z Z Z until we kind of get rid of. There we go. Is it going to go away? Yeah, that's wild. Okay, so I want to go like this and like this. Okay, and I'm just going to go like this. And like this. It's wild how it just didn't disappear. I had it commented out. You'd think that it would recognize that, but old school way. It's a little bit harder to get rid of as well, if you guys noticed. Okay. I don't like seeing stuff in my errors list. Okay. All right. Let's see. Okay. Let's continue. Do watch for numbers overrunning the size of the integer and wrapping around incorrect values, right? That's why we talked about wrapping, guys. Okay. I hope you've been following. And you know what happens when you wrap, right? Know your range. It's probably why a lot of people just use int. It's safer. Okay, do give your variables meaningful names, right? So these are given meaningful names, right? Don't use keywords as variable names, and don't use the hashtag define process or directive to declare constants. Use const. It's saying use const. Okay, this is a do. Do. Do use const. Okay. And don't. Okay. Do's and don'ts. Let's continue. Enumerated constants. These are fun. Enums. Maybe you heard of enums. They're fun. I like them. Enumerated constants enable you to create new types and then to define variables of those types whose values are restricted to a set of possible values. This is where we're getting into containers now, guys. Okay. If you've been following along, remember, I don't know, it would take me a bit to find what page am I on here? Okay, I'm going to see if I can find it. I hate to go back, but I just want to kind of refresh your memory on this, right? Containers. Okay, in memory, right? It's contiguous memory. Contiguous memory means box after box after box. So think of this as just a singular memory block. I guess I hope that makes sense. But each container has its own memory address. Now 100 isn't the normal memory address. Usually it's hexadecimal, okay? But for simplicity's sake, and to not use big scary words and letters, I'm just going to use 100 because the brain doesn't get scared by the number 100, right? Okay, contiguous, in contiguous blocks. I'll go over this again maybe. I should save this. I'll save that later, but there you go, okay? Containers. This is the key critical thing to understand, guys. You have to understand this, okay? How it works. This is part of the magic under the hood stuff. Okay. It's not that bad, guys. It's not that bad. Just think of each one as a house. I don't know, a house, right? Think of each container as a house. And you can have 5 people inside that house. And the house has a memory address. Right? You can look at it like that. Whatever makes it easier for you to understand. Okay? Because we're getting into enums, which is kind of similar to another word I don't want to use just yet, but called arrays. And you have to understand how things are stored in memory. Okay? All right, let's continue. Enumerated constants enable you to create new types. Okay, a new type, not a data type, but a new type. And then to define variables of those types whose values are restricted to a set of possible values. Okay, so for example, you could create an enumeration to store colors. All right, specifically, you could declare color to be an enumerator, and then you could define 5 values for color: red, blue, green, white, and black. Okay, the syntax for creating enumerated constants is to write the keyword enum. Okay, we're going to clean things up because now we're on a new concept. Okay. We're just going to clean things up. I hope you guys don't mind. All right. I'm just going to go like this. This is our new topic. Enumerated constants. So they're saying the syntax for creating enumerated constants is to write the keyword enum. Okay, there you go. Enum. Now, just like int, right? Remember, it's a type, guys. Int is a data type. It's also a type. And what's the next thing we type after we type int? We type our variable, right? And then we make it equal to something. Left-hand side equals right-hand side. Okay? This is the right-hand side. Except that's not an int, right? The program knows it's not. Okay? So the next thing we do after typing enum is we go, well, they have it all uppercase. We'll do the same. And then the next thing you type is, here's something you haven't seen yet. At least I don't think you have. The curly brackets. They're right beside your O and P on your keyboard. And you got to hold shift and hit that. So literally all I had to do is hit the left curly bracket and it did the rest for me. It's all magical. Notice that with enums, it also ends with a semicolon. So with that said, that would mean that this is also a statement. Red is our first, and then everything gets separated by commas, okay? This is all part of the syntax, guys and gals, okay? Be consistent, all right? Once you write more of these and write more, the more and more and more that you write, as a matter of fact, I like to go like this because it'll separate it when I do that. Okay, it creates more separation. So the more you type this out, the more in memory it becomes. Let's say you're gonna do cars, right? BMW, just as examples. I'm gonna look for GMC, just easy short words. Dodge, Chev. No, we'll go Ford because Ford only has, right? You get the idea. And then if you do that, you can see how like I deleted that right curly bracket and it actually organized it nicely for me. That's what I like. Okay, again, the more you type it, the more it becomes part of your memory. Okay, so this statement performs two tasks. Okay, it makes color, right? This is technically the variable. Okay, type variable. So this is what stores what's here. If you notice, int variable equals 15, for example. Oops, that's supposed to be equals. If you notice, when you're declaring an int or a float or a double data type, you notice it has an equal sign. Here it's different. The setup is different. This is kind of technically speaking, making this equal to this. It's just the format or the syntax, it's set up different. That's all. So when you're working with different types, you'll know the way to type things up. Okay, let's do more, and right, this is how we get better. So curly brackets, and then however many, I'll use the word elements because it is a word that you would use, technically speaking. Okay, so it makes red a symbolic constant. Okay, that's a symbolic constant. Okay. You can see how its value, it gave it a value of 0. It's like, how? Oh, look, blue is 1. Oh, look, green is 2. You can see that if you look at this, it's called a local variable. And you can see the scope resolution operator. I think it's called something different in that case. I could be wrong there. All right, we got to delete all this too, right? Because we got rid of that other stuff. Got to be careful of that. I think I might have a different term here because I think classes, right? But anyways, let's not worry about that too much right now. But notice it has 2 of these colons, right? Green belongs to color, and green now has the value 2. White belongs to color, and it has the value 3. Okay, these are done automatically for us. It's assigning the values. And really, I'll kind of go into detail a little bit. The 0 refers to the position that is stored in memory. I should have kept that screenshot. I'll just screen it again. I should have saved it. Not a screenshot, but the snipping tool that I did. Okay, we'll do one again. I just didn't want to bother saving it right now. Okay, right? The position, it's called the address, and I really don't want to confuse you guys, but really it's the position that it's in. So position 0, position 1, position 2, position 3, position 4, position 5, and position 6. Or you can look at it as the container number. Whatever helps, because there's a lot of things that are kind of being said, right? There's a lot of things to kind of remember, but each one of these containers is a house and it has a memory address. Technically speaking, the memory addresses are hexadecimal formats. Okay. The container is going to hold a value, which could be any random number. But each container also has a position, right? Don't confuse it with memory address. So we call them elements. Okay, each thing's an element, and what's that other word? Index position, that's the word. Index position. So index position 0, index position 1, index position 2, index position 3. Again, memory is stored in continuous blocks. 1 block, 2 blocks, 3 blocks, 4 blocks. But you just got to remember, it doesn't start, you don't count, humans count starting at 1, right? But just remember, computers are binary. So computers start with 0. So computers begin counting at 0. Humans begin counting at 1. That's why we're talking about these index positions. Okay? I'm going to leave that. But if you look here, this is the index position. Computers begin counting at 0. This concept that we're talking about right now, guys and gals, is critical. It's key. It's key to understand this. Because when you start looking through for looping through arrays or for looping through enums, you have to know when to start counting from, right? Take note, when you're writing code, computers start counting at 0. Okay? I'm showing it to you right here. Computers begin counting at 0. Just think of computers as like, oh yeah, computers think in binary, 0s and 1s. Yeah, that's what they do. So again, computers always start with 0. Humans, well, we count starting from 1. I'm going to leave it at that. I don't want to over-explain it anymore. So just remember that tiny little detail, that important little detail. This is an enum, but there's another container called arrays, and there's another one called vectors, and even strings too, right? We're going to get into, we'll be talking about this more, right? Index position. It's not the memory address. It's just the position where that box is. It's just another topic to kind of remember, that's all. Okay? The key thing is to know that computers start counting at 0. the computer uses this number here. Okay? Because, as a matter of fact, this very first position here, 0, is the memory address. It holds the memory address. Actually, that memory address is stored in color, but it stores the first index position, which is 0. Okay, I'll talk about that more. Okay, just to kind of sink it in the brain. It's a little bit to take in. Okay, color is the variable, enum is the type. Color is storing all this stuff. Yes, all of this is stored. Really, this is container 1, container 2, container 3, container 4, container 5. You can call it a block of memory, a block of memory, a block of memory. But we're not counting boxes, we're counting 0. We have to computer count. 0, 1, 2, 3, 4. Computer counting. You have to learn how to computer count. I don't know how else to say that, right? You got to break the old human counting. Humans start at 1, computer counting starts at 0. Just remember that. All right? A little bit of extra information that I gave you guys and gals, but we'll go over it again, okay? Trust. Especially when we get into working with strings and working with arrays and working with vectors. We'll be talking about this a lot. So it eventually get stored in the brain. Okay, we all know what RAM is. RAM is our temporary memory. This is where all this stuff's being stored, okay? Red is being stored at a memory location. That memory, the color needs to know where to look. The computer needs to know where to look. It looks for that first memory address, which is red. Red has the first memory address, which is also the index position. Okay? So when the compiler goes to look for the information that it needs, it needs to know the memory address, and then it'll go, and it knows that the very first position is the memory address. Okay? Each one of these has a memory address. Okay? Just remember, these are all containers, right? This container has a memory address. This container has a memory address. This container, right? But this is 0. This is 1. This is 2, 3, 4, 5, and 6. We got to count, computer count. All right. When you define a variable in C++, you must tell the compiler what kind of variable it is. This is usually referred to as the variable's type, right? If you hear the type, what's your type? Well, again, enum's a type. Int is a type. Okay, an integer is a type. A floating point number is a type. Floating points are 3.1416. Okay, this could be a float or it could be a double. Okay, it just depends on what you want to use. Remember, one uses more memory, temporary memory, which is RAM. Okay, again, when the compiler is looking for the information, it's looking for it on the stack, which is, stack is just think, all these variables are, I didn't mean to throw another word at you, but on the stack, it's another concept. These variables are being stored on the stack, also known as memory, which is static memory. Okay, remember, dynamic is in motion, running, when the program's running. Okay, we're not running right now. Right? Okay. I do apologize. I don't want to overfeed your brain too much here, guys. Again, I know you're smart, but it's also a lot of information to absorb, right? Turn your brain into a sponge. You love it. A character, right, which is a char and so forth. This information tells the compiler how much room to set aside, right? We've been over this numerous times, right? Okay, find yourself this chart, right? Just look for, I don't know, what your keywords would be. Types, data types, C++, charts, you can type something to that effect. You might find something good on the internet that's a little bit better than what I have. There's always stuff out there. Again, guys, you can resort to the internet for additional support, networking and support. There's a lot of different websites out there that give you a lot of different examples, different types of code, right? I recommend, let's get through the theory and all that, and then you can use the internet as kind of an additional support, right, for more examples. A lot of people out there, they're great coders and they have good tips and stuff, but you have to be able to differentiate between the crappy code and the good code, okay? Again, that's why we got to get through the theory. You'll be able to see through the the good stuff and the bad stuff. Okay? This information tells the compiler how much room to set aside, what kind of value you want to store in your variable. It also allows the compiler to warn you or produce an error message, right? So if we have like a syntax error, it's going to do that in the beginning, guys. Data equals 15, right? Okay. If I build this, it's going to give me an error, right? That's what it's talking about. This is all compile time. This is all compile time or errors, right? We're not running yet. Compile time is static memory. Information on the stack. The stack is just the RAM, guys. Okay? It's the temporary memory stored on the stack. Because this information is stored in the memory on the stack, I built it, and we're getting compiler error, right? Compile time error. It's telling me that I'm missing my semicolon. Again, we're doing C++ here, C# also. This is this language, which in my personal opinion is the best language. Always ends with a semicolon. All your statements end with a semicolon. It's really not that much harder to remember that. How hard is it to remember a semicolon? The compiler literally tells you that something's missing. It's literally telling you. Okay, which is great. I love this IDE. Okay, so it also allows the compiler to warn you or to produce an error message, which we just seen, if you accidentally attempt to store a value of the wrong type. Oh yeah, it'll do that as well. So if I go int data 2 equals 3.1415, right? We're now giving it the wrong information, right? Int is a whole number, guys, right? You didn't sleep in math class, right? You know this. So if I build it, okay, ooh, it didn't even give me any errors. Ooh, interesting. What if I actually try to do a calculation of some sort? Int, let's see what it does. if I try to multiply data times data 2, and then it's got to give me an error now. It has to. Okay, I'm just gonna go like this. Keep it simple. Whoops. Okay, so if I try to run that, so it does run it. It didn't even argue. That's wild. But if you notice, okay, this is good that this stuff happens, right? Because now you get a visual of what's happening. Okay, look, it's given us a return of 45. It's done the calculation. You could do it on your calculator. But notice how the return type is an integer. Okay, well, that's because I'm being explicit and telling the compiler, hey, compiler, this is an integer value. Okay, what happens if I go, let's go, which one's the smallest one? Float or double? Float is. Okay, float, right? Because it's a float, right? I'm using the wrong data type. It didn't really yell at me, which I'm surprised it didn't, but who knows? Could be the version or whatever of, right? For example, I'm using standard, right? I didn't mean to use the word version, right? Standard. Okay? So, but I have to do 2 of them to get that value, okay? And plus, think about it. If you want your return type to be a float or a decimal value, well, this has to be also a float, right? So let me build this. And if I recall correctly, you need 2 matching data types, right? As a matter of fact, this is correct because I'm telling it that it's a float. I haven't really got into data types much, but there you go. See? Now we're getting a decimal return. Okay, so if you ran a code or ran a simple calculation like that and you were getting an integer return, that's why, guys. Okay, that's why we have the data types. Let me check this. How are we doing here? Okay, we're good. All right, I gotta speed it up here. So again, kind of an older course. It should have been kind of an argument there, right? Me using int here. There should have been some sort of argument because that's not an integer, right? All right. So if you accidentally type to attempt to store a value of the wrong type in your variable, this characteristic of a programming language is called strong typing. That's another kind of there's our coding lingo word of the day. Strong typing. All right. I'm just going to go like this. Word of the day, strong typing. I know we've had a bunch of other words, but okay, each cubbyhole, right, or container, okay? I'm just going to try to use container, but if you hear me say cubbyhole, that's what I mean. Each container, okay, is 1 byte in size. It depends on the data type. If the type Oh, okay, hang on, hold up. Each one is, yeah, each cup, that's right. So each one is 1 byte. Okay, that's true. Okay, I never thought of that. So when we say integer 1, 2, 3, 4, so that means it would use 4 containers for 4 bytes. Right, that is true. Each container is 1 byte. Remember that. In memory. If the type of variable you create is 4 bytes in size, it needs 4 bytes of memory, or 4 containers. Ah, yeah. Right? I'm glad I kind of corrected myself there. So when we use int, it only needs 4 containers. Okay? The type of variable, for example, integer, tells the compiler how much memory, how many containers to set aside for the variable. Okay? That's what's up. There was a time when it was imperative that programmers understood bits and bytes. After all, these are the fundamental units of storage. I mean, yeah, don't really need to go that deep into bits and bytes to understand this concept we're learning now, right? Computer programs have gotten better at abstracting away these details. I mean, it doesn't hurt. You know that 8 bits equal a byte, right? It doesn't hurt to understand binary. Maybe we'll talk about that another time. Computer programs, okay, but it is still helpful to understand how data is stored, right? The memory is important. These details that we've been talking about today, guys, they are important to understand for understanding coding. You don't really need to understand zeros and ones and how bits and bytes all work, technically speaking. You just need to know about it, that's all. But if you want to go deeper into understanding that knowledge, you can. All right. Let's see. Well, there's actually a section on working with numbers, binary, and hexadecimal. So stay tuned. Mathematics. I love mathematics. Yes, I do. I don't even want to read this. If you get scared of math, I don't know. I'll just say no comment. I found math fun. I loved it. Size of integers. On any one computer, each variable type takes up a single unchanging amount of room. That is, an integer might be 2 bytes on one machine and 4 bytes on another. Okay, this basically boils down to the architecture. Okay, the architecture being 32-bit or 64-bit. We're on a 64-bit machine. Now, this only refers to, let's say you're making a program, guys. Let's say you only want to make your program for a 32-bit machine. Well, that's what this selecting these are for. Okay? Just because I'm using a 64-bit machine doesn't mean that I can't write programs for an x86. Okay? That's all this means. So when I'm doing this, I'm technically speaking doing a program for a 64-bit operating system. It's the architecture, guys. Now 32 bits, I don't know, I'm sure there's people still using 32-bit architecture out there. I don't know of any, but I'm sure there is. Okay, single characters, including letters, numbers, and symbols, are stored in a variable of type char. A char variable is most often 1 byte long, and that's true. A char is 1 byte. Remember, every character you see on your keyboard, it doesn't matter if it's a number, there's still a character. Okay? ASCII table, guys. Okay? you got to kind of separate the. Yeah, we look at numbers and we know them as numbers because that's how we learned, and it's mathematics and such. But when we're talking about computers and working with keyboards, every time you press a key on your keyboard, you're not pressing you're pressing a character. Okay? But it does have an associated value, integer value. We'll get into that. Stay tuned, guys. All right? I'm going to show you some cool stuff in the near future. Hopefully things start going better. Well, a little bit worried. I don't know how long I'm going to be here. If I'm going to be living in a van down by the river, I don't know. We'll see how it goes. Remember, guys and gals, sharing is caring. All right, let me continue. The endless debate about how to pronounce char, that's just so petty. Like, why even, who cares? It's just, like, I understand being a purist and all that, but if you're going to be, like, harping on people because they pronounce car, or char, like, tomatoes, man. It all still cooks the same. It doesn't matter what's happening under the hood. Okay, for smaller integer numbers, a variable can be created using the short type, right? So instead of typing int, we could type short. That would be the shorter version. Essentially, we've reduced the memory and our range just by changing that type. Okay, again, take note, your value has to fall in that range, right? I know it does. Because short does. And I guess I could say unsigned. Right? No, now knowing that they're positive values only. Okay? Unsigned. Short. There's our range, 1 byte. All positive values. A short integer is 2 bytes on most computers. A long integer is usually 4 bytes. Okay, there you go. See, again, architecture boils down to the type of architecture. Right? You could develop for a 32-bit architecture. You can. I could do it right here if I wanted to. It doesn't matter what machine you're using. Okay, and an integer without the keyword short or long is usually 2 or 4 bytes. You'd think the language would specify the exact size that each of its types should be. However, C++ doesn't. All it says is that a short must be less than or equal to the size of an int, which in turn must be less than or equal to the size of a long. So short and long, we'll just look at that quickly. Short int, long int. Short int, long int. Short int, 2 bytes. There's the range. Remember, to be explicit, you have to say unsigned if you want all positive. Okay? Long ints, it's no different than a regular int. Long int's the same. With that said, you're probably working on a computer with a 2 byte short and a 4 byte int with a 4 byte long. I don't know, there's a little bit of information. Remember, if you're following along, you would know how to return how many bytes in memory each data type is. Hopefully you took notes on that. Remembering how to type your statements is kind of important, okay? How do you access that information? If you have to go back a few videos, I don't remember which video that was. If there's a certain area that we're talking about here, guys, and if you're worried about not remembering, just pause the video, take some notes, screenshots, snippings, whatever you want to do. Use Notepad, WordPad, type your notes in Visual Studio, whatever you want to do. I gotta finish up here though. I'm gonna again start doing my streams earlier, guys and gals. Okay. Now I know maybe some of you are looking at what time I'm doing my streams, guys. Just to be clear, I'm not waking up at noon. I am a morning person. Okay. I will adamantly express this to you. Okay. I get up in the mornings. I do. All right. I am a dad, so therefore equals I have to get my butt up and get my kid ready for school, do the dad mom type things that I got to do. Okay. I'm always up in the morning. I like being up in the morning. A lot of times that's when I do my socials, or I'll watch videos just to kind of, wake up with my coffee and catch up on some social media or whatever, or watch more coding tutorials, not tutorials, but just like informational and support type videos. So there you have it. Okay, just to be clear. All right. So, but I am going to try to be on this schedule of 12:30 to about this time, Mountain Time. All right, guys, I'm on Mountain Time. Just so you know. I don't know where you are, so I don't know what your time zone is. Okay? If you want to catch me on my live streams, my kid's back to school, right? So the summer schedule is kind of messed up. I won't lie. And so, yeah. Next, we're going to write a little program. Oh, look, I'm actually going to do it. You don't even have to go back a bunch of videos. And I'll just do one here right now for you. I'm just going to get rid of this. We're going to get rid of this. I'll keep the enum. I don't know. Maybe we'll talk about that again. Here you go. So let's say we're going to go to the table here. I'll just do one of them. You could do for the rest if you want. Okay, and I'll just type one here. The size of an int. I think I already did this once, but that's why I was saying, like, you might have to go back a bunch of videos. But here's the syntax. Okay, every statement has a certain order of operations, and I already missed something. You write your standard cout, then you write these operator symbols. Okay, they're actually overloaded. Okay, the master coders did all this work for us to make our lives easier. Okay, quotations if you want, followed again by some more streams. Oh, come on. Why are you not working with me here? There we go. Okay. Standard O streams. O stream, I stream. Let's get some ice cream. Okay, and here we go. We type size of. This is an actual method that's already been done for us, guys. Imagine it's part of the IO stream. It's a method. Okay, again, methods and functions are two words which mean the same thing. A method is a function is a method, but a method is part of a class. A function is outside of a class. That's the only difference. One belongs to a class, one's kind of doing its own thing. Okay, what's the data type? So we want to know what the size of an int is. You can change your data types right here. These are passing in your arguments. Okay, we're passing in. Okay, and then pop. More quotes if you want more information. Remember, if you want a space, you have to add a space in your string literals. End with a period. Use your escape characters for a new line, because why not? And then always end your statement with a semicolon. There's another way I could do this. I could go like this. Now, you pick the style of code, line coding that you want to do. It's up to you. However you want to end your line is up to you. Okay, let's build it. Hopefully I don't have any issues, and let's run it. Boom. The size of an int is 4 bytes. And the \t gave us 2 tabs. It's no different than hitting the tab button on your keyboard twice. That's the exact same thing. All right, guys and gals, I appreciate you. Again, you can do the rest with short, long, char, float, double, and bool. Okay? I'll say it again. We've already done int. So short, long, char, float, double, and bool. Okay? Bool is just true or false. That's all. We'll keep it like that for now. Okay, we'll talk about bool more. It's a data type. Every single one of these is a data type. Data types. All right. I'm done, Johnny, with for today. Hopefully things are going to go well, and I'll see you guys tomorrow. Have a great rest of your day. Well, tomorrow might be actually 4 or 5 days after, but that's okay. It's great to have you guys. Right? I love it. I appreciate you guys watching, learning here alongside with me. You guys are awesome. Beautiful, intelligent people that you are. Keep it up. Keep up the great work. You're doing great. You truly are. All right, Johnny Whiskey Tango Sharp coding. Appreciate you. We'll see you in the next video. Take care for now. Wherever you are, have an awesome rest of your day, evening, morning, noon, and night. Whichever it is. Take care for now. Johnny for now saying peace and peace.